Welcome to Ask and Learn.
In this question, we are required to use the mathematical induction to prove 1 times the factorial of 1 plus 2 times the factorial of 2 plus 3 times the factorial of 3 plus blah 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 n times the factorial of n is equal to the factorial of n minus 1 of n plus 1 minus 1. Okay. To use the mathematical induction, we want to begin with the base. For suppose n is equal to 1, we know the left side is equal to 1 times the factorial of 1, which is equal to 1. While the right side will be equal to 1 plus 1, the factorial of 1 plus 1 minus 1, which is equal to the factorial of 2 minus 1, which is equal to. So when n is equal to 1, then it has been checked. Now suppose we want to construct the induction. We want to give the inductive hypothesis. Now suppose for any k which is greater or equal to 1 and less or equal to n, we always have 1 times the factorial of 1 plus 2 times the factorial of 2 plus blah 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 plus k times the factorial of k is equal to the factorial of k plus 1 minus 1. This is our inductive hypothesis. For any k less than n, we know this is true. Now let's consider k is equal to m plus 1. Okay. For n plus 1, for k is equal to n plus 1, we know we want to show this is true for k is equal to n plus 1. Then let's begin with the right from the left side times the factorial of 2 plus blah 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 plus n times the factorial of n plus m plus 1 times the factorial of n plus 1. Okay, this is the left side. And by the rule of summation, we can first compute the summation from 1 to n. And by our inductive hypothesis, this summation is equal to the factorial of n plus 1 minus 1. Okay, so the left side is actually equal to the factorial of n plus 1 minus 1 plus n plus 1 times the factorial of n plus 1, which is equal to the factorial of n plus 1 times 1 plus n plus 1 minus 1, which is equal to n plus 2 times the factorial of n plus 1 minus 1, which is equal to n plus the factorial of n plus 2 minus 1. So we've actually proved, by the inductive hypothesis, we've actually proved this guy is equal to the result in the last line. That means for k is equal to n plus 1, we still have this identity. Okay, that means this identity is true for any positive integer n by the mathematical induction.